Hi, in this video we will explore how to transfer a staging buffer of pixels into an image object in Vulkan. The image object is a special data buffer on the GPU, and when transferring data into it we will also need to request from the GPU that this buffer takes different layout formats. First for accepting data, and then to reformat it for being used by the graphics pipeline. So we will start with this method called transition image layout. It will take the old image layout and the new layout. Then we also want a method called copy buffer to image. It will take the buffer, the image, and the size of the image. Let's now copy both of these and paste them in the CPP file. I will shortly create their bodies. In this time, I will show you how we are going to use them first. If we go back to where we left off last time, here we had the staging buffer and the destination image prepared. The first thing that we want to do is transition the image layout. It should go from undefined to transfer destination optimal. Then after we copy the data, it should go from optimal for transferring to shader read-only optimal. And in between, we will call this copy buffer to image. We pass in the buffer, the image, and the image extents. The copy buffer to image is actually pretty straightforward, so let's start with that function. We begin and end a transient command buffer. We have to specify a buffer image copy region. The buffer offset will be 0. The buffer row and length will also be 0. Buffer image height 0. Next, we initialize the sub-resource and we start with the aspect mask. The image is considered a color texture. We're not using MIP maps, so MIP level is 0. Base array layer is 0 and array layer is only 1. Next, we set the image offset to be zeros. And here we have three-dimensional values, and the image extent will be the image size on X and Y, and a 1 for the depth. And I will also have to static cast this into unsigned integers. Next, with this copy struct initialized, I can call command copy buffer to image. Pass in the command buffer, the image itself, the layout of the image, the region count, and the region address. Now, we also need to transition the image layout. I will copy over these two command buffer creation and ending function calls. After that, we will create this object called vk image memory barrier. On this one, we have to set the S type. We set the old layout and the new layout. We're going to set the source queue family and the destination queue family indices as ignored. The image is our image. The sub-resource range is again the color bit. And we just saw these values for the sub-resource range in the copy buffer. So I'm not going to repeat them out loud. Now we also need to set the source and destination stage for the pipeline. This barrier is responsible for making sure that these commands are executed in the correct time. And based on what we're transitioning from and to, we have different stage flags. So if we have the old layout undefined and the new layout transfer optimal, then the source access mask is 0, and the destination access mask is going to be the transfer right stage. The source stage is top of pipe, which is the beginning of the pipeline, and this operation has to be done by the time the transferring of data takes place. Now, the next part is when we're converting our transfer optimal into shader optimal. We have to set the same values, but the source values will be taken from the destination values from the previous settings, and the destination access mask is shader read bit, with the destination stage the fragment shader. Next, we can call this command pipeline barrier. We pass in the command buffer, the source and destination stages, 0 for flags, 0 for memory buffer barriers count, and no for the pointer to memory barriers, 0 and no for the buffer memory barriers as well. And finally, we pass 1 for the image barriers, and we pass in our barrier address. Finally, after all of this, we have to destroy our image. We call destroy image, and we also call free memory to free the device memory that we allocated for the image.